Hey everyone, and welcome back to Summarize Science. You've probably seen videos of Spot, the amazing four-legged robot from Boston Dynamics. These robots are incredible at navigating tricky terrain, but how do they actually understand the world around them? Typically, a robot's map is just a floor plan of walls and obstacles. But what if a robot could create a map that not only shows where things are, but also what they are? That's exactly what this research is all about, giving a robot a semantic map, a map with meaning. Researchers took a Spot robot and equipped it with a suite of sensors. You can see the payload here. It includes a 2D LiDAR, which is like a spinning laser that measures distances to build the basic floor plan. It also has two special cameras, one to track the robot's own movement and another that sees in both color and depth. This diagram gives us a great overview of the system's brain. As the LiDAR and tracking camera build the 2D map, the color camera is constantly looking for objects using an AI detection model. When it spots something, like a person or a chair, it uses the depth information to pinpoint its exact location in 3D space. Then, it projects that object as a labeled marker onto the main map. But here's the cleverest part, shown in this flowchart. The robot doesn't just blindly add every detection to the map, which would create a huge mess of duplicates. Instead, it has a two-stage memory system. When it first sees a potential object, it puts it in a short-term buffer, like a mental notepad. Only after seeing the same type of object in the same location multiple times does it get promoted to the long-term map, making the system confident that the object is real. If it sees a confirmed object again, it simply reinforces that belief instead of creating a new one. So, does it work? Here you can see the results from a real-world test in a lab. On the right is the actual scene with two people and two chairs. On the left is the map the robot built in real time. The blue cubes represent the confirmed objects it has locked into its long-term memory, correctly identifying and tracking the person and chair. The system successfully kept these objects stable on the map, even as the robot moved around and saw them from different angles. So to recap, this system allows a quadruped robot to build a map that includes the identity and location of specific objects. It does this in real time, on the robot's own computer, using a combination of LiDAR and camera data. The key innovation is its memory system, which filters out noise and prevents duplicate objects, creating a stable and reliable map. This is a huge step towards robots that can understand more complex, human-like commands. Imagine telling a robot to go to the fire extinguisher in an emergency or find the person in the West Wing during a search and rescue operation. While there are still limitations to overcome, like improving depth accuracy, this work paves the way for more intelligent and useful robots in our world. That's all for today on Summarize Science. If you found this look into the future of robotics interesting, be sure to like and subscribe for more. Thanks for watching.